Sure. Yeah. Hey, everyone. And thank you, Andrew, for having me on. Yeah, my name is Thomas. Always been super interested in software and electronics engineering and computing, things like that, just technology in general. Got into iPhone software development when I was around 9 or 10. So that was around the 2009, 2010, right after the iPhone SDK launched. Got into building Objective C applications and then got into Android with Java. And then from there into kind of more open source applications and hardware as well. So I also worked on a 3D printer project called Orb, which was a polar 3D printer, which would the idea was to be modular and also much faster than current machines at the time. And then I've also worked on a lot of different augmented reality applications and now working on augmented reality hardware. Uh, and then kind of across multiple companies, different startups, bigger companies, things like that. But now back in startups, which is really fun. So that's just a little bit more.
Yeah, that sounds awesome. I mean, we'll dive into all of it today, but let's start off. What was like, after you learned the basics and all that stuff, what was your first big coding project?
Yeah, I think it was the first big one was probably Earth Fortune, which is in the TEDx talk that I gave, and it was kind of a relatively simple application compared to a lot of the I guess larger scale production applications that are out there. But for me, it was a really cool opportunity to learn how to do UI development, how to talk to the device for iPhone and iPod Touch at the time, as well as iPad when it came out eventually. Um, and yeah, it was kind of that, and then I of course made some more after that. But I had been messing around with software before that as well, so kind of learning Python and C and places like code.org didn't exist at the time, but GitHub did and SourceForge did. So I was able to download open source code and kind of mess around with it, which was really fun. I think it's really important to have reference like that, which is why I'm still very bullish on open source. One of the reasons, because I think that people learn in a lot of different ways. Some people learn best from books. Some people learn best from lecture and classes, and some people learn best from doing hands-on development or learning from other sources. Kind of from reference that's already out there, and that's definitely the way that I learn best. So.
Yeah, I agree. I'm a big fan of open source. I think that's really what led to a lot of our innovation nowadays. I mean, GitHub, think about all the projects on there that people have built on and just really helped us advance a lot with everything. So I think I'm with you a lot there. And also, like, even platforms like Scratch coding, a lot of beginners, but even more advanced people go on there just for fun. Like, all of that is open source. And Scratch is a big place for, young coders to learn. So I love that that's open source and all of it. So yeah. So then after you learned Swift and Objective C, right, for the uh, iPad and all that stuff. I mean, back then it was Objective C, right? That was before Swift.
Right.
Yeah. What would you say now is your favorite programming language?
Oh, now it's definitely Rust for memory
Okay.
management reasons. I've done quite a bit of work in C and C++ and Objective C, of course. Objective C is really neat because you can also pull in C and C++ code, and it kind of works pretty seamlessly. We colloquially we refer to this as Objective C++, but Rust definitely is nice because it is a high level language, kind of like C, but it certainly not as high level as Python or something, but it is relatively high level like C, and but it takes care of a lot of the memory allocation challenges that people that developers will often introduce um, into either embedded systems or into just normal code. So I think there's some applications where Rust does not make sense, but in most cases, Rust is really nice.
Yeah. And what projects have you made with Rust?
So the platform for my last company called Teleportal, we actually wrote in Rust. It was, or rather, the first versions were built in TypeScript and mixture of TypeScript and Python. But then and then some C in there as well, and then we moved over to Rust for the third gen platform, which was definitely really nice.
Gotcha. All right. And let's go a little back. We're jumping all over the place here, but after, you've made your first projects, for fun and put those on the App Store, how did you decide to do a TED Talk, right? Did you just like approach them? What happened?
So I actually didn't know what TED was before I gave that talk, and or when I was invited. There was I had already been working on this app club at my middle school, and so I was in sixth grade at the time, and the leadership of the school noticed that this was happening, and this was a public school in the LA area, and they were working on a TEDx event, which is it's like an extended event, right? TEDx is an independently organized TED event, and they called my mom on a Sunday morning or something and said, "Hey, is your son, interested in sharing a little bit more about what he's working on with a group of people? Probably be about 300 people." And I said, "Yeah, sure. I'll come over and talk about what I'm working on in terms of the apps and the app club." And we did not expect it to go as far as it did. We figured it would just be in the community. Maybe some people on YouTube would resonate with it, but we never anticipated that it would go as far as it did. It definitely opened up a lot of doors for me personally, but also I've heard from multiple people at this point, having gone to university and uh, even beyond. Like every once in a while, someone will approach me and say, this talk is one of the reasons that I got into coding. So that's really cool to hear.
Yeah, I mean, that's awesome. I don't know if you know, because, since we post a lot on YouTube, we have some creator like extensions for Chrome and stuff. So I can see how many views a video gets per hour. And your original TED Talk on YouTube is still getting 104 views per hour,
Wow,
which is
crazy.
crazy. Yeah. And 11 million in total, which is also insane. But yeah, I remember watching it probably a while ago when I was first really getting into coding again. Like I, touched on a little bit like with Scratch and stuff, but in 2020 during COVID, we all had a lot of free time. I started coding again, and that was really with Python. And I remember I was just searching up tutorials all the time on YouTube, and I remember this popping up as one of the videos, and I believe I watched it then, and then I revisited it recently, and I was like, hey, I wonder what he's doing now. And then, I mean, that's what led to this interview, really. But yeah, I
Cool.
mean, that's just, crazy that how much it blew up. And I mean, it makes sense. That title, a 12-year-old app developer is probably going to get a lot of clicks, especially back then. But I
Yeah.
think, I mean, that video probably inspired a lot. And I mean, me too, really to keep going when I watched it when I was really, starting out. But probably helped a lot of kids, either your age, younger, a little bit older, and even like older people going into college decide to, like you said, decided to go into computer science and all that, which is just awesome. Just really helped get coding into, more places for kids, which is awesome. So after that event, you said it opened a lot of doors. What was the next big thing you did?
Yeah, so after that, I was working on a couple of different projects. One was called Orb, which was a 3D printer project. That was primarily hardware. I actually built some smart glasses, so I was really interested in Google Glass at the time. Google Glass was the catalyst for me to get into AR and VR. Launched in 2012, of course, before Oculus was announced, before the Pebble watches were shipped, before Apple Watch came out by multiple years. Really a device that was ahead of its time, and it's something that I still wear to this day. You'll see it in my profile picture. But yeah, so I was working on a mixture of AR and 3D printing, and then I started a laser tag game in AR that was basically designed to just use the sensors and radios that were found on modern smartphones at the time. There was no SLAM tracking, which is kind of a advanced way to do augmented reality. I didn't have that in the project at the beginning, but it was mainly just GPS and IMU, or inertial measurement unit data. So things from the accelerator, or values from the accelerometer, gyroscope, compass, that kind of thing. And worked on that. Did a lot of tests in the park with my friends. Just we'd go to the beach or the park or wherever we could go to test this laser tag game, where you could just play laser tag anytime, anywhere on phones. And the concept worked pretty well. There were of course bugs and all the normal things that come with software development. But overall, it was sticking and in terms of experience. So I was able to go out and get some pre-seed funding for that from a venture firm here in Silicon Valley called Lightspeed, and work on that in high school, kind of on the side while I was also doing school. So that was a really cool project. That became my first company, Teleportal, and ran that for multiple years.
Yeah, I mean that's incredible, especially at that age. I know a lot of teens nowadays, and that's really why we love to have entrepreneurs on this podcast to talk to a lot of those young entrepreneurs about like starting companies, especially that young in high school and stuff, and getting funding. I mean that's very difficult, and I mean from doing that and convincing big VCs at that time. Do you have any advice for teens trying to start a startup, get some pre-seed funding, and stuff like that?
Yeah. So the first thing is to bootstrap as much as you possibly can. And bootstrapping for software looks very different than bootstrapping for hardware. Bootstrapping for software typically relies on access to a computer or some device where you can actually write your code. Um, I know that there are ways to do it on tablets and iOS now, but some form of that, and you can go really far with just computer access. And if you don't have that sort of access at home, maybe at the school, there's access or something like that. But with hardware, it's significantly more challenging because there is a lot of just part cost. And if something breaks, it's not like you can reboot the computer. You just have to, either fix it or get the right tools to fix it, or, God forbid, buy a new part in certain cases if you let the blue smoke out of the chip by putting too much power through it, for example. So there's differences. I would say for software, try to iterate on concepts and don't worry too much about the code quality being 100%. You will continue to learn over time what code, how you can kind of do software well. And with teams, like, also building software like that with teams is very different than building software uh, for yourself. There's of course version control and some of the other logistics that come with that, but there's also just how certain like coding patterns are very different in collaborative situations. How you write the code, how you comment, if you comment in certain cases, and it's kind of a lot more involved. But in terms of funding, venture capitalists in Silicon Valley typically look more for full time people to be full time on their projects. You can get certain grants though. So there is a fund called 1517, which I love. They're amazing people. They also are co-founders of the or Danielle, who runs this, is one of the co-founders of the Teal Fellowship as well, and they basically provide grants. I forgot the exact name of the grant, but it's 1517 fund, and you can kind of get uh, a grant that will let you um, work on your project, whatever it may be. Of course, the Teal Fellowship is also available, and then there is there's some others like Z Fellows by Corey Levy. So there are more and more kind of small check funds that will do this sort of thing for high school, and then once you get into college, that's kind of where things get really interesting, right? Do you want to stay in college? Do you want to drop out or stop out to work on something? Maybe you don't go to college at all and maybe do a gap year. That can be a very challenging thing for a lot of families as well,
Yeah.
to hear that their child doesn't want to go to college. So but the thing is, whichever path you choose, there are options. And so yeah, I would look into some of those grants for funding, but there's you can go quite far with just software.
Yeah, and I love the age that we're in, that there are so many platforms and funds looking to help out young entrepreneurs. Like you're saying, Z Fellows is a big one. And the Teal Fellowship and a lot of places like that that will be like, if you've dropped out, if you didn't go to college at all, you're just bootstrapping right now, trying to start up a company, we will give you money to, continue with that, right? And I mean, that's awesome, right? You even go back, just like, say, I don't know, like, 10 years, there were barely any funds focused on kids and teens, or people that dropped out of college, even just that age. And we all know, the famous stories of all the big entrepreneurs that dropped out of college. And I think that's really helped us get to this point where more young entrepreneurs are out there and creating, really. And that's awesome. And so after that, where did you take this game? You said into your next, or you developed that into Teleportal, right?
Right. So this game was called YTag, as in Wi-Fi tag. YTag became Teleportal when we turned it into an SDK. So this is actually when I met my co-founder. My co-founder's name is Ryan, and we met actually doing hackathons together. So we found out that we worked really, really well together. And at this point, it was just me on YTag. I had a couple of friends helping me before that, but by that time, it was I was the only one working on it, and uh, Ryan and I were, working together at hackathons, just building cool augmented and virtual reality software, and we found out that we worked really well together. So we ended up becoming co-founders in Teleportal, which was an extension of YTag. We took the underlying technology that powered YTag, kind of ability to do massively multi-user AR and VR networking with a data model attached, or iOS, Android, eventually Magic Leap, Oculus, you name it. We were on all the headsets. But yeah, we turned it into a software development kit that any developer could use for their own games. So instead of us being the game publisher, we were a kind of more business to business developer tools company. And we were that for quite a long time. We had an SDK. We had, as I mentioned, the three major revisions of the developer platform, and then we ended up going back more into the consumer route with 3D animation tools. But it was a really interesting. It was about 7 years. About 4 of those years were full time.
Gotcha. I mean, I like how you were saying that, all those pivots, right? You started with the one app and then you expanded that, and then you became an SDK for other businesses trying to do that, or other projects. Then you went back to, or went to the 3D animation space. I mean, that kind of just goes to show how, businesses can transform into different things. And, you got to always be innovating and pivoting. And I mean, that's awesome. So after that, right, you said that was 7 years you spent
Yep.
on Teleportal. What was the next big thing you worked on?
So after Teleportal, I was working on kind of figuring out, okay, I know I want to stay in AR. I'm going to build hardware, specifically glasses. And having worn Google Glass for so long, there's a lot that I think Google got right with Glass, namely the portability. Even the field of view is actually pretty decent. They nailed a lot of the like small interface and industrial design elements. Of course, there's room for improvement, and there was a lot of public backlash against Glass, but I think they were on the right track. So what I'm working on now is a company that is building spatial computing hardware and trying to essentially reboot that dream. But between this company and the last company, I worked at another company called Curio, and Curio is working on these plush toys for kids, mainly for kids that can talk back to you. They have an AI element to them, but they are just designed to help kind of a screenless future for kids. Um, so I went there, and after my last company, after Teleportal, went and worked with Curio for a bit. Did firmware engineering and some electrical engineering, and got to go to our factory. So it was a really cool experience. But we've actually been able to ship between April of last year when I joined, and um, December, around December, we were able to go from concept to full production of the toys, and that's when I started working full time on the new company. But yeah, it was a really cool project to be a part of.
Yeah, I mean, it sounds like it. And I know you've gone back and forth a lot, and a lot of it you've been doing both. But what do you like more, hardware or software?
I don't like either particularly more than the other. I think they were both really important, and I'm fascinated by computer history. I think that computer history shows a lot of software, hardware playing together in really interesting ways. And at the end of the day, software is just a way to tell the hardware what to do. And in fact, you can encode software in the hardware. They're kind of there isn't a at a certain point, if you go far enough down in the stack, there isn't a huge difference between them. It's one of the reasons we have this concept of firmware. Of course, when you abstract higher and higher into like you have an operating system, okay, that's definitely software. But or an application running on an OS, that's definitely software. But I'm really interested. Kind of my sweet spot is right at the firmware level. Um, I don't quite go as low as the silicon right now, but somewhere between we have this set of system on modules, system on chips, or even just the raw CPU, and we have RAM, and we have other peripherals. We might have radios and other things. So I really enjoy writing software and doing electrical engineering at that level of the stack because they have some really interesting. Um, there's a lot of optimization so you can do as well. So it's kind of an optimization challenge for me too. But now that I'm running, Raven, which is the new company, obviously they're most of my my time is balanced between doing actual hardcore electrical engineering and firmware engineering and leading the team and getting funding and hiring and things like that.
Gotcha. All right. And I know software is, nowadays so easy to get into. You don't even need to download an IDE, all that. You can get that stuff online tutorials, all that. Do you have any, like, a great first place to start with hardware, like an Arduino or Raspberry Pi? Any suggestions like that?
Yeah, Arduino and Raspberry Pi are great places to start. There are companies like Adafruit and SparkFun that provide kits, so I would highly recommend going there. Both of those companies, specifically Adafruit for me, but both of those companies helped me develop a lot of electrical engineering skills, even just putting things together early. I think the first my first entrance into hardware was with the Arduino Uno, the original revision, and I just hooked that up to. I would put an LED in pin 13 and you know in ground and not put a resistor inside. It was like that was my very first entry. But yeah, Raspberry Pi is a great place to start. Arduino is a great place to start, and I would definitely check Adafruit's Learn system because they have a bunch of tutorials that are open source as well as kits that go along with these tutorials, and you can learn how to build all sorts of cool things: robots, sensors, speakers, small devices, things like that.
And I know we were actually talking in the TSARP Discord server the other day about the Meta glasses that I recently got, and one thing is they're not AR or VR; they're just all audio and stuff. And we were talking about, you asked me would I like if there was like a visual element or if it was all audio, and I think definitely I love AR and what we're going into there and that space and the technology innovation there. Um, but what I do like for right now about the Meta glasses is that I feel like they're very seamless, right? Because I feel like they didn't try to go above and beyond because at this point, I don't know if they could be as slim, but I feel like the future is having glasses like the Meta glasses that are so you barely ever notice if you're walking down the street, you would never know someone could be listening to something or with those glasses. I think the future is being able to have your whole cell phone in a pair of glasses, and it sounds like that's really what you think too, that you're really envisioning. But what is your favorite thing about the Google Glass?
It's probably how lightweight Google Glass is. The comfort of glass is unparalleled with almost any other device that I've used that has a display, and that it doesn't seem like it would matter too much for even someone who's really into tech like I am, but it is incredibly important. And I agree with you on the Meta Ray Ban, right? It looks like normal glasses. It looks like something that is not really going to be noticed as anything incredibly different. I think there is a market for people who are want to make it a fashion statement, not necessarily a tech bro fashion statement, but like a fashion statement, like wearing Prada sunglasses or something, there is going to be a market for that. There's also going to be a arguably much bigger market for people who want to wear glasses that have a display in it that look like normal glasses. But as you mentioned, there are a lot of technical challenges with that. Um, I think that the smartphone replacement is coming for sure, and that is where I'd ideally like to be. And I think even a lot of desktop operations can be replaced. But I think that initially it's going to be more of you kind of have to blend kind of there's an expectation or there's people are already used to maybe the Meta Ray Ban, which only has audio, and then you kind of have to slowly bring the market up to speed. Just shipping a device that's immediately like let's say we even had the technology to have a full, you know, immersive kind of smartphone replacement that looked like normal glasses. It is unclear as to whether the market would actually fully adopt that immediately right now. I think there's a technological um, barrier, but there's also a social barrier and kind of a cultural barrier to this, and it's something that has to be balanced really, really effectively. Um, but yeah, back to your question, I think Google Glass, the comfort. I mean, the entire device weighs under 38 grams, which is really, really light for one of these devices. Vision Pro, for context, weighs about 600 to 650 grams based on the configuration. The Quest 3 is around 540 grams. And most of the weight actually for glass is positioned kind of on the side and on your right ear. It's not on the front. And there's actually research that shows that if you put more than 40 grams on the nose, it's over. Like you can't, most people will not be able to wear it all day. So it's a really tough number to hit. It's a number that we are striving to hit at my new company. No more than that on the nose, but um, yeah, I mean it's the comfort is so important, so important.
Yeah, and like you're saying, there's just a lot of barriers there that obviously a lot of people, including yourself, are trying to break down. Like you mentioned, but also just barriers with affordability, right? That's another thing I like about the Meta glasses is that they are a little pricey for just like they're more than regular glasses, but they're a very great intro device if you're trying to get into some cool tech like that. Definitely a lot cheaper than the Google Glass or something like that. But yeah, they're only, I believe, mine were a little more expensive because I wanted the transitions. But if you just want the base device, it's like $299. So a great almost intro device, like I was saying. But yeah, so what do you even more to what you were saying, like the future is like having all those cell phone capabilities or having advice like that on your face and in glasses. What do you envision with like the future of that fully? Like, do you think AI is incorporated into that? Like, what is the future there?
Yeah, to me, AI is an implementation detail. I actually disagree with the AI wearable hype. I think it doesn't really make sense. The AI wearable makes sense if AI is an implementation. It's so this is one of the things that I learned kind of the hard way building the first company, and I'm still young, so I could be wrong on this, so take this with a grain of salt. But based on where I my current thought and previous experience, people buy experiences, they don't buy the technology, and often you can ship inferior technology and people will still buy it because the experience is better in some way, and maybe the experience isn't better in every way, but maybe it's good enough and there's something really nice about the experience that even if the tech isn't architected really well, uh, that makes people choose that particular device or software or whatever it is over something else that is architected better. And as an engineer, this really bothers me because I obviously want to be building something in the best way possible. So there's an interesting balance there, and but I think that with the AI wearable hype, a lot of the issue is not even it's not even the fact necessarily that
Materiality.
it's billed as an AI wearable. It's that a lot of the companies that are building these don't seem to wear their own device out. And this is true for a lot of companies that feel, I guess, the need to lock down their intellectual property. And I don't see at the end of the day, right? Is that is that really helping the product to just keep it locked up in a lab? I mean, it worked for Apple under Steve Jobs with the iPhone and other products, but I would argue that most companies that is not going to work well for. So, for example, at Raven, all of our staff will be wearing prototypes out in the wild every day, and that is, sure, we run an intellectual property risk, but the risk of shipping a product that people actually don't want because we focused on one thing, one experience, or one piece of technology that no one really cares about is, you know, we need to balance that.
Yeah, that's actually incredibly interesting what you just said there with, they're wearing it out, but you're trying for it not to also get out before release, intellectual property and all that. But yeah, I mean, like you said, you need to make sure that this is advice that, everyone wants to wear daily. And the only way to figure that out really is to wear it daily and wear it throughout. But that's a very interesting risk, that you're facing there, and just to think about, almost just something to think about. But yeah, we have, I think, one question in the chat right now. Someone asked, how do you think about the materiality of good glasses outside of the glass/lens part itself, like wood versus plastic versus steel versus something else?
Ooh, that's a great question. And a lot of that, again, still comes down to comfort, but it also comes down to aesthetics because the first thing you have to get about glasses, or the first thing that has to be achieved, is it has to look good enough that someone says, oh, I might want to wear that. That's the first barrier. If that barrier is, if if you can't cross that barrier, it's over. And if they put it on their face and it's uncomfortable, it's over. So those are kind of the two barriers before you even get to utility. Utility is kind of a tertiary thing. But with materials, it's it's possible to make different materials, and this is really more of an industrial design question. It is possible to make a lot of materials very comfortable. Like you could make wood comfortable, you can make aluminum or titanium very comfortable, and glass even. Like there's even certain plastics don't have to feel like cheap plastic; they can feel really really nice. And so I think it's important to like mix those as well and try a lot of different um, try a lot of different uh, materials in different prototypes and wear them around, even if they're not fully functional prototypes. So this is one of the things that we're up to as well. Um, yeah, I don't have a specific answer on what will work necessarily for everyone, but I found Google Glass's titanium band with the plastic insert in the behind it to be really comfortable. But yeah, I think at the end of the day, it just depends on aesthetics and comfort. And it's possible to make plastic look good and feel good. It's possible to make metal look good and feel good. It's really how you form it.
Yeah, looks and how comfortable it is, really two of the biggest variables here, along with a lot of others. I mean, this is very advanced stuff that you're working on, and a lot of different factors to think about. I know we gotta wrap it up soon, but I know there's another question in the chat. Someone asked, direct projection onto the eye or projection through the glass itself. What do you think about X-Real?
Yeah. So X-Real, most of X-Real's glasses are using what's called a bird bath optic, and I think they have some others that are using a different strategy. But the issue with bird bath is that it creates a really thick, you know, basically a thick prism where you have to have an optical combiner that's combining the light from the outside and from the display. And it's nice because you get really large field of view. And bird baths are actually pretty optically efficient. You don't need to have a super bright display to create a bird bath. You can actually save on power and save on, the display technology can be a little bit easier, and then you get your amazing immersion. You can get fields of view that are much much higher than something you'd find on Google Glass with its small beam splitter, or even with one of the other waveguide solutions. But yeah, I think that sort of setup makes a lot more sense for you know for these immersive devices like a Magic Leap or even a Vision Pro or Quest, it doesn't make as much sense for daily wear augmented reality, at least not right now. The waveguides are getting better and better. The light engines are getting better and better. Um, we'll see. Like it's going to improve, but I think there's kind of the AR VR landscape is kind of bifurcated right now between AR and VR, and trying to create something in the like the Goldilocks zone of it's really lightweight and it's also really high field of view is I'd say probably at least 5 to 10 years away. Um, but yeah, I mean, I think waveguides are interesting. I think birdbath is interesting. Like beam splitters, like what Google Glass has, is super interesting. There's been some hybrid waveguides that we've seen from companies like Ant Reality. Uh, Everyone's trying all these different approaches, and I think no one's really found the like on its own a display and an optical setup is not enough. You kind of have to combine it with like what software is going to be on it, what battery is going to be with it. But once someone finds the right combination of these things, it's going to be really, really good.
Yeah, I mean, there's also a lot of companies working at this, which is why I think we've had so much advancement lately. And I can't wait to see what the future holds. I mean, we could keep talking about this for a long time, and I would love to have you back on in the future. But I think we got to wrap it up for today's episode. Yeah, I mean, thank you for joining us. Do you have anything else you want to mention about anything?
Yeah, I'd say, I mean, there's going to be a lot of, for anyone out there who's working on their own projects, there are going to be a lot of ups and downs, and building anything, engineering, science, whatever, arts, like the really, this is a combination of all of art and engineering. And when you attach yourself to what you're working on, because that's your pride and joy, right? It's like what you want to build. You can get really emotionally attached to the project that you're working on, and that can make the certainly the successes feel amazing, and also it can really motivate you to work harder and to uh, find some really interesting uh, ways around these challenges. But it can also, when the project fails, or when certain things aren't going well, it can cause a lot of issues. And so just try to recognize that failure is just success in a different context. um, there's going to be a cosine wave, just like life is a cosine wave in general. And just celebrate the small wins and work through the challenges. And um, know that every single person out there, no matter how successful they appear on the outside, they've been through a lot of different ups and downs as well, and it's a universal experience. So it's not something to be worried about. Like, oh, I'm a failure. No, you're not.
Yeah, I think that's a fantastic way to encapsulate, really the journey, whether it be with startups or just building a project. Um, yeah, really just a great way to look at it. And everyone, like you just said, everyone has their ups and downs. And you might consider one thing a failure, but it's just you're gonna have your next success. And what you learn from that failure will probably help you a lot in your next success. So thank you so much for joining us today, Tom. Thank you all for tuning in, and we'll see you back here tomorrow to all the viewers, and we would love to have you back on in the future, Tom.
Yeah, thanks, Andrew. Would love to come back.
All right. Bye, everyone.
Bye.
Bye bye.